Hey, ladies and gentlemen, let's go over 4.50 in Brownlow-May-Burston. That way we can understand how to determine some oxidation states. So we want to know, in this case, what the oxidation state of CO is in this crazy compound. So we have lithium COO2, okay? So doing this, we have to know certain rules about brain fart, about our oxidation states. So oxygen is almost always going to be a 2-. In lithium, remember, if it's a metal, typically it's just the charge that it normally forms. So lithium is going to be a 1+. So all of these elements have to add up to the overall charge of the substance. In this case, this is a compound, so the overall charge is 0. So we have 2- times 2. There's 2 of them, so that's a 4-. And now we have a 1+. So now we need to have as many positives as negatives to make sure that they cancel out. And so that means that cobalt must be a 3+. Okay? Well, now we do the same thing. So for part B, okay, we have sodium aluminum hydride. That's weird to see, but that's fine. Okay, sodium now is a, I'll change colors here, is a 1+. Let's see. And then hydrogen. Now, hydrogen is funny. Hydrogen is almost always 1+, except when it's with a metal. And so now with hydrogen, this hydride, when it's with a metal, the hydride is 1- with 4 of them. That means we have a 4- there. And then sodium is still 1+. And so aluminum is going to be a 3+. So aluminum is a 3+. So now C in CH3OH. Okay? So, and I think that this is just about, this is mainly about knowing the rules of oxidation states. So for CH3OH, again, hydrogen, except when it's bonded to metals directly, this is going to be a +1, and there's 4 of them. Oxygen is always 2-, so it's a 4+, because there's 4 of them. Oxygen is 2-, so that means that carbon is a 2-. Okay? How about nitrogen in gallium nitride? Okay, well, for question D here, gallium, Ga, when we look at the periodic table, gallium is going to have a 3+ charge. It's right below aluminum on the periodic table. Okay, so that means that nitrogen is going to have a 3- charge. Okay, how about chlorine in HClO2? Okay, well, for part E, HClO2. Remember, oxygen is going to be always 2-, and hydrogen is almost always going to be 2+. So there's 4- because of the oxygen. There's a 1+ because of the hydrogen. So chlorine is going to have a 3+ oxidation state. And now in barium, the chromium in barium chromate here. So this last one, F, I kind of went in some sort of weird order here. Okay, but anyways, so barium, CrO4. So oxygen is 2-. There's 8- because of oxygen. Barium is 2+ because that's the charge barium is going there. So this is 2+. So we need to have 6+ taken up by chromium. Okay, so that's how you determine the oxidation states in compounds. Okay, so you need to know the rules of oxidation states and go from there. Okay, talk to you later.